so that's good. We don't have that going on. How many people would actually show up this morning? So that's good. Tomorrow morning will be the real kicker after everybody goes out tonight. That'll be the challenge, right? So, good morning. So we're going to get started here. I'll say it one last time. Those that are coming in, please sign up at the sheets if you don't mind, so we can keep track of who attended which sessions. We appreciate that. So, without further ado, we'll get started here. We have Alexis this morning here presenting as a technical lead in the refinery and petrochem sector for data acquisition systems, works for ESC Spectrum. She holds a bachelor's degree in chemical engineering and started working as a DAS implementation engineer for ESC Spectrum for the power gen clients. Over the past 4 years, she's been focusing on designing, implementing, and developing standards for refineries and petrochem DASs, primarily in the refinery sector around RSR, JJA, and GHG. Over the years, she's worked in dozens of refineries, petrochem facilities, and acts as a technical resource for the rest of her coworkers. Outside of work, she enjoys an avid board gaming thing, which is I have seen in action before. It's quite impressive. So she's always got a game on attitude when it comes to meeting DAS needs and requirements. So without that, we'll let her share her experiences. Thank you.
Good morning, everyone. Can you all hear me in the back? All right. All right, good. So GHG reporting. As a DAS vendor, I get to see a fair amount of our clients and how they're handling various reporting needs. But some of you might be wondering specifically why we're talking about GHG, greenhouse gas reporting. Didn't those requirements come out like a decade ago? And yes, they did. And right now, we've been more working with power gen prior to the past 4 years. What happened about 4 years ago was that MAC-CC basically with flare requirements. And when those came out, we started seeing a lot more refineries start to focus on looking at a DAS as an option for handling their reporting needs. And what we found was that a lot of our clients, after they got in all of the reporting requirements for flares, monitoring everything that they needed to, then went on to the further units and kind of went in order of their pain points, what took the most time, so that they could then help automate those and speed up their reporting needs. So typically after flares, a lot of sites would then have us proceed, go on to more of the cracking units and sulfur recovery units, and then from there, handling the heaters and boilers just kind of in order of complexity and what they needed help with. Now about 4 years later, we've seen a lot of our clients where this is kind of the last portion of their needs for reporting on our end, and they're having us then take up and since we have our system recording data all across their facility now we can finally bring everything in and meet their GHG reporting needs. We've also seen some clients handle this in basically the reverse order, where they're looking at bringing in their GHG monitoring requirements, flows and everything into a DAS to be able to just kind of use it as a test bed for their DAS system, learn how the software works, get used to it, and then kind of go in reverse order so that they are handling their other reporting needs the same way they have been, and learning how to use their system well and effectively before then going on to meet all of their other needs. So main differences between GHG moving from power gen to looking at refining and petrochem. They're really not that different in terms of the types of calculations that we're doing, mostly just building totals and using emission factors to calculate what we need. So in that regard, there's not too much difference. The main difference comes into more of the types of units that we're working with. A lot of those catalytic cracking units, lot of flares. So there's a little bit of differences in meeting those needs, but it's not anything different than we've done really in the past with helping customers bring in data, properly average and total that data, and then spit out a report for their needs. So why a DAS? We have a full presentation on this at 11. I'm just going to go through some quick highlights. Main one being automation. The more you're able to automate, generally the better. The more automation you have, the less time you're spending doing all of the more tedious tasks, and the more time you have for the important work that you need to get done. Another benefit is migration from spreadsheets. Spreadsheets typically don't handle large quantities of data very well. They take forever. They can get easily corrupted. You have all of these spreadsheets where they're also not great for long-term data storage solutions, where you want something that can hold the past 5, 10, however many years of data you want to keep on hand, but at least past 5 years worth of data for most requirements. Then another good benefit about this is transparency with a DAS system. Often you don't have to go through tracking down through PLCs or DCS logic or a bunch of series of pi tags to figure out how something is being calculated. The calculations generally right there in front of you, where you can see here's what we're taking in, here's the calculation, here's what's coming out, and it's easily available without having to dig through a lot of supplemental documentation or ladder logic, which no one wants to have to go through most of the time. Change tracking is also a big benefit. Anytime changes are made to data that was collected from an analyzer for any reason, or any time that there's an equation change, any of that can be easily tracked and have a record of that and why that change was made. And then another benefit is standardized reporting. This is going to help out for more at a corporate level with a bunch of the same standard reporting formats, don't have different facilities having kind of their own special reports. And it's also easier for any successors to come in and here's the reports that we've been using. You can quickly generate them, and they don't have to dig through a spreadsheet to figure out what someone was doing beforehand. Then another big one is specifically for GHG is viewing those that year-to-date data based on the averages and totals that we're able to collect from that day. So from the start of the January and then to even today, you could look through that data and see, all right, here's all the averages we have, here's the totals, here's what we're looking at as far as our yearly GHG emissions. And this was a big one for a lot of the customers that I've worked with, that it's based on several sites would just generate these values come reporting time, and they didn't really have a good understanding of where they were at prior. So this was a big help for them. So rest of what we're going to cover today, gonna run through planning, just kind of what you need to be thinking about to start planning out a DAS system, or even just planning design of GHG calcs in general. A lot of the potential pitfalls that people run into, things that are easily missed and can cause errors in your calculations, as well as DAS considerations, kind of points that you should be thinking about or at least have documented somewhere to know how your system is working. So Planning is usually the most important step. Ironically, this is one that we're not going to cover that much in this presentation. But good planning is essential for pretty much any project that you're working on. And during this step, this is the time to reevaluate decisions that have been made in the past years. Someone made a decision at some point like a decade ago. Maybe that person was you. Maybe you have different understandings of the regulations and different opinions on how something should work now versus when you did 10 years ago. So this is the time that you should really look and see, all right, why are we doing this? What was the purpose of doing it this way to begin with? And are we, more importantly, doing this the right way? Sometimes you get into a routine of just we've been doing it this way, so we're just going to keep doing it this way, and it might not necessarily be the best or right way to do it. You'll want to make sure that you have detailed documentation before any programming of systems begins, as well as keep that level of detailed documentation after your implementation, just for people in the future to look back on and understand why decisions were made. The DAS vendor should ideally provide this documentation, but you may want additional supplemental documentation. Often as a DAS vendor, we just get an answer to a question of, how do you want this done? Here are options of what we've done for other customers. And we get an answer back, but we don't necessarily see all of the hours of research that you all have done to come to that decision. And keeping that why documentation somewhere will be helpful, if not for your future self, then for your successor. So a big way of designing these systems in general, you just want to start with the reporting requirements and really work backwards from there. If you're the one trying to set the system up, maybe not necessarily in a DAS, but just get your system set up, that's generally the best recommendation for going about setting these up. Another that I found more specific for GHG is looking at separating out the units by the subpart C tiers that are listed, the tier 1, 2, 3, and 4, and then more further along for various other subparts and unit types, like all of your flares, all of your FCCUs, all of these more complex units that really depend more on the analyzers that you have in place that are a little harder to template, because the goal should be that you have just a standard of, here's how we're going to handle this heaters or a group of heaters, depending on how you're reporting. And we want to then apply that to every other case that we have as best as possible. Again, that's usually difficult for flares, just based on the analyzers and other factors, but it can be done, and you want to try to standardize as much as you possibly can. All right. So these are going to be areas that are where mistakes are pretty common, and this first one's very simple. It's just STP, standard temperature and pressure. Which standard? Because that's going to be very important. This matters a lot for your molar conversion constant and emission factors. And are you using the right standard? Often we get a scuffs per hour reading, and it's okay. It's corrected. So which correction is it? Is it 68? Is it 60? And we need to make sure that it's the right correction for what the application. Another potential pitfall is, how do you build the average or total, and at what time period or interval is this calculation done out? Are averages and totals built daily, monthly, quarterly, annually? Are the CO2 calculations done daily and totaled up, or monthly and totaled, or quarterly, or just annually based on average data as well as other totals? And typically in the regs, this is well specified of, you shall do this calculation every day if possible, or you should do this calculation every month based on the averages for every day within that month, or based on the totals for every day within that month. And then for your methane and nitrous oxide calculations, are those done at the same interval that your CO2 calculation is done or not? That's another area where it's usually it is, but sometimes it isn't. For example, if we look through subpart Y for a flare calculation, assuming that we have a GC mass spec SEMS vent gas flow meter, and we're using equation Y-1A from that subpart. For that equation, it specifies that the total volume of flare gas combusted over a day, so we'll total that. Then we have the average molecular weight of a gas over a day and the average carbon content over a day. And then we have that, taking all of those values, we use those in the calculation to calculate CO2 daily. Daily CO2 values are then totaled for the year. And then we do the methane, nitrous oxide, CO2 equivalents calculated using those annual CO2 values. So we're taking values for a day, doing a calculation, totaling that calculation for every day within the year, and then doing another calculation for that year value. And this is the kind of level that's detailed in a lot of the regulations for how you are supposed to build these totals. So the complexity here isn't so much in the calculation, but the averages and totals and making sure those are done at the correct point. Other potential pitfalls that I've seen, subpart Y flares. There is a section that if you monitor the gas composition, calculate CO2 emissions from the flare using either of those equations. The important part about these equations are that they are not using the higher heating value. And often what's happened is that now we have requirements for monitoring that composition, usually where maybe there was a mass spec or GC in place beforehand, but now that was a process analyzer rather than a SEMS. But now with like MaxCC, that's now a SEMS. And now it says in this section that if you have that data, you need to use these calculations instead of the higher heating value. We've seen some sites where they've always used the higher heating value, so that's just the way that they've been doing it. And when bringing up these, it's important to look through and see, have there been any analyzer updates at your site where these updates would cause you to need to use different equations? And that's an important part to take a look at. All right, so DAS considerations when you're building a DAS. These are the items that you should really try to document and make sure that you have recorded somewhere, or at least consider when you are building the system. The first one's going to be that temperature pressure correction for STP. Main reason for this is going to be that transparency of, okay, we get the actual flow data in, we correct that ourselves. Now we have it at a known standard of, we corrected this to 68 degrees or 60 degrees Fahrenheit. And that calculation is transparent, and you don't have to go dig around in a flow meter somewhere to find that information out. And typically I'd recommend this as just as many calculations as you possibly can, putting those in a DAS just mainly for that same level of transparency, and doing that carbon content calculation, just as many of the calculations as you can, depending on what needs to be calculated versus lab sampled. Which, speaking of the lab sample data, big consideration is, how is that going to get into the DAS? Is that going to be entered in directly by a tag into the DAS? Is that going to be brought in through Pi or some other system? How are you going to have that data in the DAS so that the DAS can use those values. And then another consideration is, when should it apply to the calculated data? Does the lab sample results need to start the day, month, at the start of the day or week or month or quarter or half year the sample was taken during? Does it go from the date of that sample forward to the date of the next sample? Or does it go from the date the sample information was entered into the system forward? These are all very different, because if, say, the lab sample was taken, then analyzed at a later time period, and even later that information was entered into the system. Okay, so now we have that information, but it was entered in at a significantly later point. So would we go back and apply that from the actual time the sample was taken, or go back even further and the start of that day, week, month, quarter, or half year the sample was taken during? And these are the levels of details that it's important to iron out, and that programmers have to consider when designing the system. And it's important to remember that if you aren't the one making these decisions, someone out there is making an assumption, and that assumption may or may not align with your own thoughts on how this data should be handled. So another consideration is how you're bringing analyzer readings into the DAS system. Is it going to be through Pi or DCS or some other data aggregator that you want that data brought into the DAS? Or the usual problems with this are that we typically don't see the analyzer status information, such as fault indicators or like low sample flow information like that. That's generally lost, and that is important to have, as well as maintenance indicators and indicators that a validation was being run. This type of information is important to keep on the data and know when you need to exclude data. If the DAS is getting readings directly from an analyzer, this is usually preferable, because we make sure to keep that analyzer status information from getting data directly out of an analyzer. That analyzer generally has signals that is, okay, here we had a fault, here we had a chiller fault maybe, or a sample flow fault, or just a generic analyzer fault. And then the DAS has tools for excluding those periods of data, as well as periods of maintenance or validation, because it has indications for those. And this is important for the requirements for building a valid hourly average per Part 60 requirements, and can be used in emissions averaging and totals, and doesn't need to be substituted. For those who aren't familiar with this requirement, we're calling a valid hour or good hour per these requirements. And we're considering valid data as data from an analyzer that isn't in a fault state, and that is reading process gas and giving us process gas results. Data is also not missing due to power loss or communication issues. These requirements specify that you have to have at least one valid data point, so data that isn't bad and that isn't considered in fault or isn't missing. So at least one good data point in each 15-minute quadrant that that unit is operating. So that would just having a little diagram up here where we have yellow highlighted as good minutes. We only have 4 data points for this hour, but based on this definition, that would be considered a good hour, because there is a single good data point in each one of these 4 quadrants. During an hour containing calibration or maintenance, that requirement shifts a little bit. It's just 2 valid data points at least 15 minutes apart. And this is one of the things that a DAS really excels at doing, this taking this minute level data and doing this kind of analysis to determine if that data is good, or if we need to exclude that data and then follow the GHG substitution methods. And the consequences of you either missing these periods of bad data or needing to go back and manually exclude this data as it takes time, and you might accidentally be including data that you really should have excluded because there was a maintenance period, and or this caught a little bit of validation from readings, or there was a fault in the analyzer, and so that data shouldn't be included, but sometimes you don't necessarily have all the information you need to be able to go back and properly exclude all of that data. So other DAS considerations is if you want to use the common pipe approach for a bunch of heaters, it's easier, but is it better? And from what I've seen, it really depends on how much of a view you want on your GHG emissions. Do you want to see the details of a single heater and how much it's contributing to your GHG emissions? Are you good with the aggregate? And what I found is a lot of sites are typically just good with that aggregate. They already have a good idea of what units they have that are emitting the most CO2, and they don't really need that level of detail because they have that information elsewhere. But it really depends on your site and if you would find that information helpful versus just having that aggregate of data. Another consideration is hourly averages, average to days, months, or to days then to months, or hours averaged directly to an interval. We talked about averaging and totals a little bit before, but and the regs do a good job of really spelling that out in most cases, but there are some exceptions to this, and these mainly matter for units where you're considering the operating time of a specific unit, because otherwise these calculations just mathematically will work out the same. But if you have that granularity of unit operating data of this unit was on from this point to this point, say for an individual heater, or rather than an aggregate, which usually, at least in that aggregate, one heater is always on usually. But if you do have that unit level operating information, then we can either take your million standard cubic feet per day data and take an average of that over the day and use the operating time that we have for that day to calculate total scuffs for the day, or take the standard cubic feet per hour data and operating time for each hour and use that to calculate the standard cubic feet per day. And with that operating data, if the unit isn't operating the entirety of the day, that this calculation does matter and does come out slightly differently. We tend to opt for the hourly approach, but it depends on the site and your own interpretations and needs. Another point to consider is taking hourly averages and using those to calculate daily averages that are used to calculate monthly averages, versus taking hourly averages and averaging those directly to a month or a year value. And same difference here, depending on unit operation data, some of those hours, if you're taking those and averaging days and then averaging those to month, well, if you're only operating that unit for a couple hours that day would be weighted just as heavily as one where that unit is operating the entire day. If you're in the case where you're taking daily averages and then averaging those together for a month, versus taking every individual hour and averaging all of those together for that month. So in summary, you want to be sure that you are planning and documenting as much as possible, and that you have a good level of documentation, not just provided by your DAS vendor, but also internally. You want to really make sure that your STP is to the correct standard, that you have the correct data progression that you're using for your averages and totals, and calculating that data the way that you, the regulations require and the way that you interpret it should be. And then review any updates to any units or regulations that have been made since initial implementation that may cause you to need to use different calculations. And importantly, any details that aren't specified will be assumed by someone. And again, that may or may not match your own decisions and how you think it should be done. And you want to make sure that data is being properly excluded and substituted. And that substitution based on the GHG requirements. Typically with that substitution, most of the time it's taking the hour data before data needs to be excluded and the hour data after data needs to be excluded, and averaging the two together to then substitute for those data periods. But for cases like flow, usually that specifies looking at general process data and coming up with a different substitution method than just hour before, hour after. And in those cases, we've seen clients use stuff from taking the highest value over the past X operating data, or taking the average from the past X operating data to then substitute those values, and so that they are using as much of the data as they should be to calculate that, rather than just doing the hour before, hour after substitution, since that is the flow is usually the one that is specified needing to be substituted differently with that data. All right, so that was a lot of information. Do any of you have any questions? Yes.
Yeah,